first of all, let me introduce myself. My name is Moritz Schieber. I'm the sales engineer at Vision and Control. And yeah, the topic for today will be thermographic seam inspection. What we can do, and I will show you in the next following like 20 minutes how we address this topic. Okay, first of all, I would like to introduce and talk about our company a bit further so that you know what we are, what we do. And after that, I will step in right into the topic for today. Okay, so first of all, the main reason of our company is to make photonic-based solutions and make machines seeing. That's the claim of our company, and you will see why it is like this, because we act like a global OEM supplier of photonics-based solutions, and we also support like many companies in fields of metrology, semiconductor, glass inspection is also a big topic for us, life science, automation. So we cover a lot of many different company sectors. And our know-how is characterized by a broad portfolio of technologies grounded on photonics like telecentric lenses, illuminations, and machine vision systems. And I will show you in the following picture how we mean that. So you can see that everything was founded with optics for us. In that case, we began to produce the first telecentric lenses quite a few years ago, actually. I'll show you in the next slide. And if you have like a telecentric lens, you also need the proper illumination if you want to do machine vision afterwards. So that's why we started producing lighting solutions as well. And yeah, if you have those two things, many customers came to us and said, hey, do you also like offer the complete whole system, not only like the lighting, the optics, but also the machine vision part. So we can buy it from you from one hand, not just by 2 or 3 other companies. And that's why we started to develop and introduce our own machine vision systems into the market. Okay, where do we come from? We're not so far away in Germany. We are quite in the center of Germany, so to say. We are from Suhl on the right-hand corner. On the bottom, you can see our headquarters in Suhl. And this is where the magic happens, so to say. There we develop optics. We have like an own optical development department and also a construction department. Also like the manufacturing of the lenses and the lighting solutions is done in Germany in Suhl. So we are very proud to say that we are 100% made in Germany. Okay, so let's talk a bit about why thermography. So there's also always a challenge when it comes to thermography. So in the visible spectrum, you may not detect any defects, some defects that are hidden. If you think about mold injection, for example, some lunkers, some air bubbles inside a mold injected part, you can't see it from outside. So you have to use something that can look right through it. For example, like X-ray, but this also comes with quite a few challenges. So this is a very specific topic where thermography comes in place to detect defects that remain invisible in the visible spectrum. So that's the challenge. What's the benefit for you as the customer? Thermography is always, of course, non-destructive, contactless, and it can be used in a 24/7 operation. This might sound new to you because you might only use, so to say, some streaming cameras. I will talk about the application and how we addressed this topic on further slides. And the solution for it would be thermography, for example. This is the topic of the presentation. So that's the invisible view, and the temperature is used as the information source. So to say, you have some difference in the temperatures, and you measure them, you see them, you make them visible, and you do machine vision with it. Okay, so let's have a look about the basics and principles. But just a bit, just very shortly, I don't want to bore you with physics. So just to look at the spectrum, if we image the spectrum, we see that we are quite a bit away from the visible spectrum. So the whole infrared spectrum covers a range about, as in this image, from 0.75 nanometers up to 12 micrometers. And the relevant part for us in the thermography spectrum is like the LWIR spectrum, and this is covered in a range from about 8 to 12 microns. So this is where the magic happens. This is where the radiation, also the heat radiation from a body, is mostly coming from, and this is where we're looking at when we're talking about thermography and the use of machine vision. Okay. So how's such a camera working? In principle, so you see there's the pixel of a thermo camera. It's called a microbolometer, and as you see, it's quite easy to understand how it works. You have like a thermoresistor, and the resistance of this changes accordingly to the heat that is coming on the resistor by the LWIR radiation. And yeah, this change in conductivity or resistance is then analyzed by the camera, and this information is then used to display the according image and to do the machine vision, of course. Okay, so now we dive into the, I guess, very interesting part for you. So what are typical applications that come with thermography? Okay, there are some typical applications. So as I mentioned before, there is like the plastic injection molding, where you can see defects right from the bat. So when it comes from out of the machinery, injection molding machinery, you can directly see if the part is like a defect or not. On the bottom, if you look at my cursor, you can see an injected molded part for a company that is producing parts for the automotive seats. And you can see like this little nose here is not very well injected. It's not very well molded, and that's a defect. It's called bad here. And on the right hand side, you see the good image, like the good part, that it's molded perfectly. So with that, you can directly see the benefit for you. So you are simply using the difference between the temperatures. You don't have to use any additional lighting, and you can directly have a look at the part if it's still at least a bit hot, and then you can see directly if there's a defect or not. Yeah, there are, of course, pressure die casting, where it can be very interesting to see if there are any air bubbles or different materials like oxides inside the material that have a different emission coefficient. And you can also see it like in the picture. Soldering applications, welding applications. And then a very, very interesting case, the sealing of sealed pouches. And this example is shown you on the bottom left-hand corner. There you can see like a pouch with a coated material that is sealed. And of course, you can see that the seal goes right through. There are no interconnections. There are no defects inside it, no air bubbles. It's like a full seam of the pouch, and yeah, they can use the thermography perfectly for inspecting those things. Hot forming, laser cutting, process with active cooling, heat preserving, melting of plastics. These are all applications. And on the upper side, you can also see like active and passive thermography. Like on the left-hand side, you can see there is an active thermography or passive thermography going on, because you can see like the if the bottle is filled up perfectly or not. For example, like if you look at a Tetra Pak for milk, for example, you can't look through the Tetra Pak, but with the thermography, you can see if the Tetra Pak is completely filled up with milk or not. On the right-hand side, you can see an example for active thermography. This is of, I guess, the most common thing. If you think of thermography, it is used to inspect whether a part gets too hot or not. For example, with computer industry, where you look on some boards and you want to see if the CPU, for example, is getting too hot or if there are any shortcuts on the board, then you can use, of course, thermography as well. Okay, benefits for you. It can be automated 100%, like machine vision that you know in the visible spectrum. It reduces scrap and it it optimizes your process, your manufacturing process. Okay, let's dive into a very specific example of thermographic sealing. I will show you some pictures afterwards, but let's talk about where is this used. This is used. This is very interesting for sealing of pouches and blisters for sterile components in the MedTech industry. If you imagine, like, you have to be 100% sure that your packaging of, for example, a blister with some pills in it is completely sealed and there are no defects on the seal. Otherwise, the pill could be inusable or not usable anymore because of some changes. Water leaks in, and you can't use this product anymore for human use. Sealing of pouches blisters in the pharma industry, pouches and blisters in the food industry. Like if you think of a packaging of some beef meat, so to say, it's also very important that there are no defects, no air bubbles, no lunkers, nothing between the seal and the plastic that it's molded on or sealed on. And with thermography, you can do 100% inspection of this, without touching it, and you can be sure that everything is sealed perfectly 100%. And also, if there are some participants out of the MedTech sector, life science sector, all those processes, all those inspections can make validation processes very easy and faster. And all of those things that I will mention afterwards can also be validated for medical use. Okay, so let's dive into some pictures. You can see here a plastic pouch, a good sealing of a plastic pouch. There's not such a high temperature, so it's a very low signal here. You can see some defects or some bad parts, some bad sealed parts. If there are air bubbles between the plastic, between the two plastic sides, and you can clearly see them here in the upper picture with those hot zones, hot circles that are red here. So they cool down a lot slowly, a lot more slowly than the sealed parts, of course, because there's air inside. You can see a folded pouch and some defect inside it, some material inclusions, and those you can also very clearly see on the images. So it's very easy for any machine vision system to detect those systems because they are so clearly, they can be so clearly seen on the image itself. Okay, and also it works with aluminum coated plastics that are used, mainly in the MedTech, in the pharma sector, as far as I know. So you can also see the hot zone is perfectly sealed. Also down there is also perfectly sealed. But now there are some bad examples. If, for example, there is a metal object detected between the seal, you can also clearly see it here. Also some material inclusions as well for also aluminum coated plastics. Okay, and so maybe you might ask now how to implement those thermography inspections into your process. And I wouldn't be here as a sales engineer if I wouldn't show you our solution, how we address this topic. Many customers asks me, hey Moritz, isn't it extremely easy just to use a FLIR A70 streaming camera, for example, just put it there at the process and do some machine vision with it. And I also asked the customer, Okay, how do you do it with the SPS, with your SPS, for example? How do you address this topic? How do you control your machine with the data coming from the camera? And then it gets very quiet. So we have a solution there. Our software is capable of reading out the data coming from especially the FLIR cameras. We have an NDA with FLIR, so we get the data from the camera, from the sensor, and we can do image processing on the pixel level with it. And yeah, now we can do whatever you want to do with it. So you can connect it with your SPS, for example, via Profinet. You can connect it with your backhoff process control via EtherCAT. So this is no problem anymore. You just have little industry PC from us or from you, for example, our software on it, and then you can simply do machine vision without the needs of doing some other extremely complicated ways. Just do it in the software, and you can also set up a web HMI with our software, so you can control everything via a monitor, for example, that is already mounted on your station, for example, like on a Siemens monitor if you have it. And yeah, then there's the advantage for you to combine both the thermal and the visual machine vision, because you can also add like many cameras, up to 16 cameras to our systems and run them at the same time. So it's absolutely capable of multi-camera systems. You can do a lot of it. Okay, so if you want to know more about this, please feel free to let me know. Just give me or send me a message or go to our website, and there you see also our contact details. There you can see a lot more that we are capable of doing. Okay, so let's get to a conclusion, outlook, and the questions and answers. So to wrap it all up, thermography is the ideal complement to classical machine vision that you all know. There's a wide range of applications: injection molding, welding, soldering, fire prevention as well. We haven't talked about that. And also, of course, the seal inspection. And in the future, there will be more automation, AI-supported evaluation, and we can also assist you with that, because we also have like a strong software development department that is capable of combining the image, the thermal image, with a very strong AI model. And you can also do the AI things that everybody is talking about. Okay, I hope we managed, or I managed, to spark your interest in this topic. There are my contact credentials written down below. Please feel free to contact me if you have any interest in the things I mentioned. And I would give it back to Peter now. And I'm very interested in your questions.
Where does thermography save the most money compared to traditional quality checks?
Yeah, it definitely is. The advantage for thermography when it comes to money is where you can't have like a big lighting setup, for example, like in the injection molding machine. That's the biggest advantage for thermography. Or when it comes to sealing, of course, it saves a lot of money, because you only have to set up the thermo camera, don't have to adjust anything with multi cameras, one looking up, and the illumination is coming from the downside. This is not so easy to set up. With the thermography, you can easily set up those applications: injection molding, fire prevention, and this is where it's the best to use, and it gives the best return of money for you.
Next question. In thermography, do we need to use special illumination or just the long wave ER camera?
Yeah, so of course there are both sides. You can either do it passively or actively. If your process already has some temperature gradient in it, you can use the gradient. If there isn't one, you can simply apply heat to the object, and then you can see the radiation coming from it.
Oliver, there's a question for you, but you're still mute. Before you answer, liquid lenses. Do you also have telecentric lenses with a liquid lens?
Yes, we have some standard telecentric lens options that can be combined with liquid lenses. So here we also cover different options between 1 time and 10 times magnification. So please feel free to reach out to me and I'm happy to explain more.
Question to Moritz. You just mentioned the controller for 16 infrared cameras. Is it also possible to overlay a real picture of a machine vision camera to the thermography picture so you can see more details or edges, something like this?
Still muted.
Much
It's a
better
very
for the answer.
yeah interesting question. So we had to use something as Oliver maybe mentioned, like a multi-aperture system, where you look down with 2 different cameras and then have to overlay the pictures of it. But I guess it would be doable. Yeah.
What do you think are the actual trends in optics? What will be next becoming big? Is it liquid lenses, telecentric lenses, customization?
Is it a question for me or to
For
to
both
both of
of
us?
you. But also the audience can answer if they have an answer. So Oliver, maybe you like to start?
This is a great question, I would say. I think what is physically possible in terms of resolution, and yeah, we already reach our limits in terms of what is possible for lenses. But yeah, I think the trend is more, yeah, going to even higher resolution lens series. So we also have something upcoming for 4/3 inch, 2.74 micron. So yeah, I think the trend also in the telecentric field goes yeah, to even higher resolution, bigger sensors. That's what I believe will come.
Moritz, do you have an answer?
Bigger sensors is also quite a topic for us. Many customers ask us about very large sensors in the last few months or years. This is something that we also want to address more. But when it comes to software and machine vision in general, maybe it was like me now, it's all about AI and surface inspection. That's a very specific topic. So AI surface inspection, but done with a telecentric lens and not with an endocentric lens. This is something I see is coming up quite a lot.
There's also an answer from the audience, and I know the person. Extremely long WD in telecentricity above 500 millimeters is also could be also a topic for the near future. Also a big topic, and you mentioned thermography, spectral imaging. Do we need special optics for hyperspectral imaging or sphere imaging or can we use the usual optics for that?
No, that's simply not possible because like normal fused silica glass is not transparent to the IR spectrum. So you have to use like coated glass, for example, with germanium glass, and this is you get those lenses with a FLIR camera, for example, also, but we can also develop new lenses with a coating for special needs, if it's or if it's possible, or if the customer wants it, so to say. And when it comes to sphere, this is a bit more easy than the IR thing. So there's also the possibility to use normal lenses that we have in our telecentric range, but then you have to look which side of the spectrum or which side of spectrum you are using the sphere thing, but and how much of the sphere gets to the sensor then. But this is no problem then. But with the LWIR spectrum, it definitely is a problem, and you need special coatings for it.
Oliver, do you have a remark to that answer?
Could you repeat the question one more time? I could not
Yes.
understand what
Do
you
I
said.
need special optics for SWIR, long wave infrared, or for spectral imaging, or can I use just the normal optics?
Yeah, I think from experience, customized solutions are necessary here. We don't really do long wave infrared coating for lenses, but yeah, customized solution would be definitely necessary.
Mhm.